Hi, my name is Blake, and for my learning target video, I will be teaching you about learning target number 6. Now, word for word, learning target number 6 states that you must know, use, and apply the Pythagorean theorem, distance formula, and midpoint formula. Let's get started then. Pythagorean theorem states that if you have a right triangle with legs A and B units long, and the hypotenuse is C units long, then a squared plus b squared equals c squared. Now, the Pythagorean theorem is obviously named after Pythagoras, who lived 2,500 years ago in Greece, and they thought about numbers differently. They didn't think about them as on a line. They thought about them as ratios, because they didn't have fractions. So, when they didn't have 1/2, they thought about it as 3:6. Same with 3/4, they thought about it as 3:4, and everything was just in space. So they obviously didn't have a number line. Also, they didn't have variables, so when Pythagoras came up with his theorem, he didn't say a squared plus b squared equals c squared. He said that the square of a plus the square of b equals the square of c. Also, he was a cult leader and was a little crazy, as he was deathly scared of beans. But anyway, that's a story for another time, and back to the theorem. There are many ways to prove this, but I'm going to use an origami way to prove the Pythagorean theorem. The first step to proving the Pythagorean theorem with paper is to obtain a square. Now you can do this by folding along the triangle and then cutting off this strip of paper. Step is to fold it in half this way, and then again to form a square. Now what you want to do is fold it in half again diagonally, like so, to create a triangle. Now you don't have to be precise with these folds, this is just a guideline. Next, what you want to do is fold this part down, and then this will determine how long and skinny or short and fat the triangle is that you'll prove. So you unfold it, and then you have a square inside of the square. So now you just need to extend the creases of the square. Now that you've extended the creases, you have a column of 4 squares, or rectangles at least. Now what you do is you fold from this corner along this corner to form a diagonal. So let's see, hold on a second, and then there it is. There's the somewhat straight fold, and then all 4 triangles like this will be equal, so you can do that for the other 4 sides. So now that you've folded back all 4 triangles, you can create c squared by folding them back, like so, and then since all 4 side lengths are the same, the area is c times c, which is c squared. Now you had to fold back 4 of the triangles to do this. Now the question is there a way to get to fold back 4 triangles to get a squared and b squared? Now a has a side length obviously of 1 square here, and then b is obviously 3 squares here. Now the answer is yes. If you rip along this crease right here, you can fold back these 2 triangles to get a squared, and then fold back these 2 triangles to get b squared. So now you can definitely say that a squared plus b squared equals c squared. So another, more traditional way to prove the Pythagorean theorem is to take this right triangle and to duplicate and rotate it to get this figure. Now, the first thing I see is that the area of this square is obviously c squared, because the side lengths are c. Now what I want to know is there another way to get c squared without just writing c squared? The answer is yes. you can take the area of the big square minus the 4 right triangles. So c squared equals big square minus 4 triangles. Now, first off, what I want to know is the area of big square. Since all side lengths of the big square are a plus b, I can say c squared equals a plus b quantity squared minus the 4 right triangles. Now I want to know the 4 triangles. Now the triangle formula is a equals 1/2 base times height. So the base in this case is a and the height is b. So area equals 1/2 AB. And then you need to do this for all 4 right triangles, so you get c squared equals a plus b quantity squared minus 4 1/2 a times b. Now, first off, you can simplify this part of the expression to get c squared equals a plus b quantity squared minus 2ab. Now you can expand a plus b quantity squared to get c squared equals a squared plus 2ab plus b squared minus 2ab. Now these two cancel out, so you're left with c squared equals a squared plus b squared. So the Pythagorean theorem is important because now you know if you know the lengths of any 2 sides of a right triangle, you can find the third length. For example, if this length is 3 and this length is 4, and you want to know what the hypotenuse is, you can use the Pythagorean theorem and substitute 3 and 4 for a and b. So you get 3 squared plus 4 squared equals hypotenuse squared. Now you can say 9 plus 16 equals c squared equals 25, and then c equals plus or minus 5, since both 5 and negative 5 squared equal 5. Obviously, the answer is 5 because you can't have a negative side length. So another use of the Pythagorean theorem is that if you know the length of the hypotenuse and the length of one of the legs of the right triangle, you can find the length of the other leg. So for this problem, say you're a sailboat captain and you want to find the distance between where the sail connects to the mast and this corner. You can call the distance A, and then the manufacturer of the sailboat tells you that the distance from the top of the mast to where the sail connects to the mast is 48, and that the sail's length of the hypotenuse is 52 feet. So you can plug those values into the Pythagorean theorem to get a squared plus 48 squared equals 52 squared. And then you can use a calculator to get a squared plus 2,304 equals 2,704. And then you can subtract 2,304 from 2,704 to get a squared equals 400. You can square root both sides to get a equals square root 400 equals 20. So a equals 20 feet. Alright, so now we're going to take a break from the Pythagorean theorem and go into the coordinate plane. More specifically, we're going to look at the distance and midpoint formulas. We're going to start with the distance formula. Now, say you have 2 random points in the coordinate plane with coordinates x sub 1 and y sub 1, and then x sub 2 and y sub 2, just 2 random points. What the distance formula says is that the length or distance between these 2 points right here is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so to prove the distance formula, we're going to need to create an additional point down here with the coordinates x sub 1 and y sub 2. Now what this does is that this creates right triangle, so we can use the Pythagorean theorem to find the hypotenuse. Now, since this line is parallel to the x-axis, and this line is parallel to the y-axis, we can say that the distance of this is the absolute value of y sub 2 minus y sub 1, and the absolute value is just to ensure that it's a non-negative value. And then conversely, we can do x sub 2 minus x sub 1 is the distance for this, since the y-coordinates are the same, and then for this, the x-coordinates are the same. So we can plug those values into the Pythagorean theorem to get x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared equals distance squared of this. Now, you can discard the absolute value symbols at this point because all numbers that are squared will return a non-negative value. And then to get the distance instead of the distance squared, you need to take the square root of all of this and the square root of distance. So you'll get d equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So now we're going to do an example problem with the distance formula. And say you want to find the distance between these 2 points, point A and point B. Point A is at the coordinates -7, 1, and point B is at the coordinates 5, -5. First off, I'm going to call point A the x2 and y sub 2 values, and then I'm going to call point B the x sub 1 and y sub 1 values. So now I'm going to substitute those values into the distance formula to get the distance equals square root of -7 minus 5 squared plus 1 minus -5 squared. Now, since this is the subtraction of a negative number, it's actually addition. So you can, instead of saying 1 minus -5, it is actually 1 plus 5. So now I'm going to simplify this to get the distance equals square root of -12 squared plus 6 squared. And then I'm going to further solve for the expression to get d equals square root of 144 plus 36. And then distance equals square root of 180, since 144 plus 36 is 180. And then I'm going to simplify this to get the square root of 36 times square root of 5, since 36 is a factor of 180. And then, so distance equals 6 times square root of 5 units. Alright, so Mark goes to summer camp, and then in the morning he goes from the cafeteria where he eats breakfast up to the archery fields and then over to the dock for canoeing. Now he wants to know how far he walks each morning, assuming he takes the shortest path. Now, there's a map available from the top view of the campgrounds, and it's divided into grids. And then this grid resembles a coordinate plane with the origin at this point in the center. And then the shortest distance is a straight line, so he would have to walk from this point to this point, and then from this point over to this point. And then one of these grid units is equal to 1 kilometer. Alright, so the total distance equals the distance of this line plus the distance of this line. Now we need to find the points, so we're going to work our way down from the origin. So the entrance and exit to the campground is at 0, and then -2, and then his archery position is at -1, 1. And then the dock of the canoeing station is at 1, 2, 3. So now we have all our points, and we just need to substitute them into the distance formula. So we're going to start with this line. So d equals square root of 0 minus -1. And again, when you subtract the negative, it's actually addition. So we can just say 0 plus 1 squared plus, that would be -2 minus 1 squared. So then we can simplify this to get d equals square root of 1 squared plus -3 squared. And then we can continue to solve for this equation to get d equals square root of 1 plus 9, and d equals square root of 10. So this distance is equal to the square root of 10 kilometers. Now we're going to remember this for when we add this distance and this distance. Now we're going to work on this distance, and then we're going to do the same thing. So we can say the distance formula and then substitute these 2 points in. So d equals the square root of -1 minus 2 squared plus 1 minus 3 squared. And then we're going to simplify again to get d equals square root of -3 squared plus -2 squared. And then continue to solve to get distance equals the square root of 9 plus 4, and then distance equals square root of 13 kilometers. So now we need to add these 2 distances together. So then the total distance would equal square root of 10 plus square root of 13 kilometers, or square root of 23 kilometers, which is in between 4 and 5 kilometers if you want a nice integer value. So it would be about 4.7-ish kilometers. Now we're going to shift our focus to the midpoint formula, which states that if you have 2 points that are the end segments of a line, then the midpoint is equal to x sub 1 plus x sub 2 over 2, and then the y-coordinate is y sub 1 plus y sub 2 over 2. Now this is fairly easy to prove because we can just think of it as an average of values. So the midpoint must be on the middle or average of all of the x values, and then on the middle or average of all of the y values. Now, the minimum and maximum for the x and y values are obviously the endpoints, because they're the ones that end and begin the line. So then we can use the average formula to state that for the x average, that x sub 1 plus x sub 2 over 2 equals the x-coordinate, because the y values don't have anything to do with the x-coordinate. And then conversely, we can say that y sub 1 plus y sub 2 over 2 is the y-coordinate of the midpoint. And then we can just put that in an ordered pair to say the midpoint is at x sub 1 plus x sub 2 over 2, and then y sub 1 plus y sub 2 over 2. Okay, so we're going to do a practice problem with the midpoint formula now. So what we want to do is find the midpoint of segment AB. Now point A is at the coordinate -2, 5, and then point B is at the coordinate 6, -1. We can substitute these points into the midpoint formula to get midpoint equals -2 plus 6 over 2, and then 5 plus -1 over 2. And then, since it's adding a negative number, you can just say 5 minus 1. And then, obviously, this coordinate is I chose this coordinate as the x1 and y1, and this as the x sub 2 and y sub 2, but you can do it either way. So then we just need to solve for this to get midpoint equals, let's see, 4 over 2, and then 4 over 2. So it's -2 plus 6 is 4, and 5 minus 1 is 4. And then we can simplify this to get midpoint is at 2, 2, which would be at about right here. Now you may be asking yourself, Blake, when will I ever use this in life? Well, many jobs use this, most notably in the construction industry, where engineers have to know how long a support beam will be, and then the welders and carpenters need to know how long to cut that beam. And also the electricians have to know how long the wire that rides up on that beam will be. Cartographers and surveyors also use this theorem when they're finding the length of a border between towns that may be diagonal. And then the TV industry uses the Pythagorean theorem a lot because TVs are measured by their diagonal, not by their length and width. So they have to know that theorem to measure the length of the TVs. Now engineers and manufacturers also use the distance formula when they need to find the length of a beam because the beam may not be the hypotenuse of a right triangle. But the main group of people who use this are cartographers. Now, when there's a nice straight border between two countries, like the one between Algeria and Niger, you can use the distance formula there and find the length of the border. Now, you may be asking, who uses the midpoint formula? Well, engineers use it, primarily in bridges, to make sure that the secondary support beams are placed exactly in the middle of the main support, and then this will create as much structural integrity as possible. Now you may be asking, Blake, are there any other people besides engineers that use these formulas and theorems? Actually, yes. Economic experts use the midpoint formula to predict the elasticity or sensitivity when demand changes in a product. Now this creates a supply and demand curve, which is the principle of capitalism. So this is the end of my learning target video. I hope you had fun learning about the Pythagorean theorem, distance formula, and midpoint formula.